Flight control surfaces are movable aerodynamic components of an aircraft that allow the pilot to control altitude, direction, and performance during flight. By deflecting these surfaces, the pilot can control motion about the roll, pitch, and yaw axes, as well as improve performance during takeoff, landing, and maneuvering. Primary flight controls. Primary flight control components are the movable aerodynamic surfaces that directly control the aircraft's attitude and direction about its three principal axes. These components are essential for safe flight, and failure of any primary control surface can lead to loss of controllability. They are designed to withstand significant aerodynamic and inertial loads and are connected to the main aircraft structure through reinforced hinges and actuators. Ailerons are primary flight control surfaces located on the outboard trailing edges of the wings. They control the roll motion of the aircraft about the longitudinal axis. Ailerons operate differentially, with one moving upward and the other downward, creating a lift difference between the wings. The aerodynamic loads acting on the ailerons are transferred to the wing structure through hinges and actuators. Elevators are primary control surfaces mounted on the trailing edge of the horizontal stabilizer. They control the pitch motion of the aircraft about the lateral axis. By deflecting upward or downward, elevators change the tail lift, causing the aircraft nose to rise or lower. Elevators are subjected to aerodynamic and inertial loads and transmit these loads to the horizontal stabilizer. The rudder is a primary flight control surface attached to the trailing edge of the vertical stabilizer. It controls the yaw motion of the aircraft about the vertical axis. The rudder is especially important for directional control during turns, crosswind operations, and asymmetric thrust conditions. Loads acting on the rudder are transferred into the vertical stabilizer through hinge fittings. Secondary components of flight controls. Flaps are secondary flight control surfaces located on the inboard trailing edges of the wings. They increase lift and drag, allowing the aircraft to operate safely at lower speeds during takeoff and landing. When deployed, flaps significantly change the wing camber and are designed to withstand high aerodynamic loads. Slats are secondary control surfaces positioned on the leading edge of the wings. They delay airflow separation at high angles of attack, increasing maximum lift and improving stall characteristics. Slats are typically deployed during takeoff and landing and are actuated mechanically or hydraulically. Spoilers are secondary flight control surfaces located on the upper surface of the wings. They reduce lift and increase drag when deployed. Spoilers are used to assist roll control, increase descent rate, and act as lift dumpers during landing to improve braking effectiveness. Trim tabs are small adjustable surfaces attached to primary control surfaces such as elevators or rudders. Their function is to reduce pilot control effort by maintaining a desired control position without continuous input. Trim tabs generate aerodynamic forces that reposition the main control surface. Actuators provide the force required to move flight control surfaces. They may be hydraulic, electric, mechanical, or fly-by-wire controlled. Actuators must be capable of operating under high aerodynamic loads while ensuring precise and reliable control surface movement. Control linkages transmit pilot commands from the cockpit to the control surfaces. These include cables, push rods, bell cranks, or electronic signal paths in fly-by-wire systems. Control linkages ensure accurate, smooth, and responsive movement of flight control surfaces.